Good morning, everyone. So, I am Senri Hasit, and today I'll be presenting my final year research project titled "The Multi-Modal Revenue Prediction Using Machine Learning." And the name I have given for my project is CinemaScope AI. So, this work has been done under the supervision of Mr. Callum da Silva and is aimed at solving a real-world challenge in one of the world's largest creative industries, which is the cinema. So here's the flow of my presentation today. We'll go through the background and the motivation. Then I'll explain the problem and the gap in the existing research. After that, I'll cover the aim, the system architecture, implementation, testing, contribution, novelty, and wrap up with the future work and the key takeaways. So in the introduction slide chapter, the goal of this film industry is worth billions, yet predicting whether a movie will succeed or will not succeed at the box office remains extremely difficult. So, studios spend massive budgets on films, but their decisions are often based on intuition and past trends. Uh, so, traditional methods rely heavily on past revenue trends, studio intuition, and gut feeling based predictions. However, in today's data rich world, we can do better with tools like machine learning, which is what I am doing in this project, and real time audio sentiment. And media analytics, we can create a system that provides a or more accurate, and explainable prediction before the movie even releases. And that's exactly what I'm going to do in this project, and that is what the project sets out to achieve. So the problem, so let's dive into the problem. The core problem in this current model is the core problem is the models are not accurate enough, and also the other problem is most of the current existing models only take into account the basic features, things like the budget, the IMDb rating, and some basic other features. But in my model, I am going to extend this model to take into account more advanced features like the cast popularity, the social media hype. I'm going to use TikTok API to get the hashtag views, and I'm going to use the Google Trends API to get the cast sentiment, to get the cast trends. And I'm going to use a Veda sentiment analysis model, a pre-trained model, to get the audience sentiments. I'm going to use the YouTube API to get each and every comment in the YouTube trailer, and I'm going to do separate sentiment analysis on each comment. So using the Veda algorithm, and also I'm doing a release, uh, comparative analysis in the same genre. And also I'm going to use two pre-trained models, a ResNet and a VGG's audio model uh, to analyze audio and video separately. So studios like MIAS by Lee at uh, Lee at L at MIAS focus only on pre-production data, ignoring how audience actually feel about the movie. So again, as I said, the actual feeling, like the sentiment of the comments, the audience feelings is ignored in previous papers, like in the paper which is produced by Lee et al. This leads to unrealistic predictions and high financial risk. So this brings us to the research gap. Current models fail in three criteria. So the main problem is they don't incorporate real-time social media sentiment, and they ignore competitive analysis, and also they don't analyze the visual and the emotions behind the trailer. So this is the research gap that I am uh, using in my model, and in my research paper this will be defined more specifically and will be finally achieved with the solution I have created. So the project aim The project aim of this project is to design and implement a based machine learning system that can predict box office revenue before the movie releases. In short, the aim of this project is to build a regression model that is not only data driven. The model has the ability to both hear and see. So in this both hear and see, what I mentioned is the model has the ability to see the video, the YouTube video, and analyze its video analysis, and also it can hear the trailer audio, which he can which the model can analyze the audio sentiment separately. So also I to do this I take cast trends from the Google Trends API and audio sentiment from the YouTube trailer comments, and genre based comparison. I'm going to get the competitive matrix. I'm going to use the TMDB API, and also I'm going to use the basic features on top of the sentiment, on top of the features I on top of the advanced features I built, like the budget, genre, and the release timing. Those features also will be calculated. So this in turn will create a tool that filmmakers and investors can rely on for a smart and risk aware decision making. So now let's get on to the system design. So this is the architecture of my system. It follows a three tier structure. So in the presentation layer we have the React.js UI with frame of motion and tailwind CSS and Axios for API management, and also Lucid React. And in the logic layer is the Flask API background with so I incorporate both PyTorch and TensorFlow into this model building, and this Flask API holds around 6 to 7 APIs. So I have separate APIs to get separate features, and at the last a separate API to do the prediction. And in the data layer, I have the external API. So I use a TMDB API, the Google Trends API, the YouTube API, and also even the TikTok API, which is not in terms of API. I use it with the package, TikTok package, because the API is not publicly available for free. So this modular approach allows for scalability and flexibility and real-time updates. So in the slide 8, this I will talk about the implementation. So this system uses a variety of technologies. So Python and XGBoost for predictive model, then the Peda for analyzing sentiment, and Google Trends to get the cast, the React and Tailwind for clean and responsive front-end design, and Flask for the API service, and also I have separate APIs designed for separate each and every feature extraction. I have a separate API designed in my Flask environment. So in this in the demonstration, I will explain how the system works, how what the user has to enter, and how the system fetches the data, and how the final score is being produced. Let me first of my Flask environment. Then let me up my frontend. So my front backend is up, the Flask environment is up, and let me wait for the front end. Okay. So here you can see actually a very modern and a very creative kind of creative UI for the home screen. I have three navigation pages, and so I have given a small introduction here, and I have put some data here. And so here you can see the feature importance of my model. So I did feature engineering and feature data processing, pre-processing, and also I use grid search CV to do the to get the best parameters for my model. And so here you can see actually the IMDb rating is at the top. It has a very uh, high importance, and then the budget, then the cast trends and video emotion. So these are the feature importance in the prediction model, and in my comparative analysis I get these kind of data from the TMDB API. So the number of upcoming movies, the average upcoming movie popularity, so this is counted using the TMDB rating for the upcoming movie, and the max upcoming movie popularity is the maximum of the uh, popularity, the rating, the movie with the maximum rating. So here I have mentioned that this model uses a ResNet and a VGGS audio analysis model, and the combined approach, these two on top of the regression model, and how it works, the model pre-processing insights and everything is mentioned here. So let me get down into the actual predictive page. So first of all, I'll end. So this is my UI for the prediction. So I have separate market analysis, sentiment analysis, financial analysis. I have separate fields for each and every analysis, and I finally can get the generated revenue prediction. So let me put a sample movie. Let's try Inception, and let's say that it's coming 25. So this YouTube URL is actually optional. This YouTube URL, what it will do is, in the sentiment analysis, as I said, I am taking the YouTube video. So I am taking that YouTube video using the TMDB dataset. But so in case the TMDB dataset does not have the YouTube video, the YouTube link, then whatever I will mention here will be the next option for it to search for the sentiment analysis. So let me show a idea on the TMDB dataset. So this is a TMDB dataset. This has over millions of data, and this has a separate TMDB API documentation. So here you can see the TMDB API documentation. So we can actually get everything API references. We can get each and every movies. We can get data of the movie. We can get the YouTube URLs. We can get the ratings, and each and everything it is included in the TMDB version 3 API. So let me show the React my application. So now let's analyze the movie. So you can see the cast trends has been collected, and it has detected that there is 14 upcoming movies, and the sentiment is also been calculated, which is the overall sentiment is a positive 50%, and the financial analysis, the budget is also being calculated, and this is the TMDB rating is also received, and it has done the trailer emotion analysis as well, and identified that there is 5.20% happy emotions and no sad emotions in the movie in the trailer. So you can see in my backend also. So this is the part where it analyzes the faces in the movie. So at last it has identified that there are 30 face emotions, which has produced these happy emotions 5.2%. And uh, you can see it has found the movie ID Inception, and trailer also been found, and the setting the TikTok API is also been set up. And in the TikTok API, so you can see uh, in the TikTok API the hashtag views also been received, which is 17,000 million. Yeah, so now now since all the features are gathered, so now I can add these features to the generate revenue prediction API, and it will generate me the predicted box office revenue. So here it says, so all the prediction features can be seen here, and the prediction is this the revenue is predicted to be this amount. So overall, this model is very successful, and it has a 95% success rate with a 0.1% deviation. So the R2 squared is 0.95, and so this is the overall demonstration of the project. So how it works and how the backend and the front end is connected. So let me get on to the presentation. So now the presentation is been done, the demonstration is been done. So you do now you have now we all have a kind of idea on how the model works, how the prediction is been done. So now let's get on to the testing part and the evaluation part. So in the model testing part, I have a MAE, mean absolute error, of 26 million, and the RMSE is 46 million, and as I said, the R2 squared is 0.95%. So the accuracy of this model is 0.9. So in functional testing, all the core functions, the comment, scrapping, generate, scoring, class analysis have been passed, and all the APIs work consistently. And I have done a stress test on my APIs using Postman runner as well. It is shown in the report, and the edge case testing is also been done. Fallback mechanisms where when the APIs reach the API rate limiting it's been completed with exponential backoffs, and similarly low data scenarios to test the model robustness as well. And so the validated the model is also validated using cross validation, and integration testing and edge case and sentiment reliability testing was also done. So now let's get on to the contribution and the novelty. So this project contributes to the fields in the several to the field in several ways. So first thing is it combines structured data with real-time audience sentiment. So as I said, the model takes real-time audience sentiment, and also the model takes the video and the audio sentiment separately on top of the structured data. So the novelty of this the project is the model is not only a data driven model, the model can hear and see as well. So it also introduced general competition benchmarking, which is often ignored. So this is when the competitive analysis comes into the part, and also gives a explainable prediction by breaking down into contributing factors. So each factor, whatever the importance and whatever the contribution from each feature is being displayed specifically. So together this gives the model a kind of sensory perception, allowing it to respond more like a human would emotionally and intuitionally. So in case of challenges, so as I said, I'm using TikTok API, the Google Trends API, and the YouTube API. So the Google Trends API only gives 5 requests per second. So I often comes into contact with the rate limiter of the Google Trends API, and even the YouTube API. The YouTube API only allows 10,000 requests per day. So if when I am trying to train the model over and over again, I have faced the rate limiter of the YouTube API as well. And for the TikTok API also comes with the rate limiter. And the other thing is the TikTok API which I'm using right now is not the official API. It is a library produced by a separate individual. To get the original TikTok API, I need to pay for the API and get the documentation by paying. So now let's come into the limitations. So there are few limitations. The first limitation is the data set constraint. So the data is only trained with 1000 movies, as I mentioned. So the data is only trained, the model is only trained with 1000 movies. This is because it will take very big time to do the feature extraction, more than 7 days, more than 2 to 3 days. Like if I takes 5000 movies, it will take approximately like 7 days for the feature extraction itself, uh, because most of the time, as I said, even in the Google Trends API, I only can send one request per 5 seconds. So it will take very huge large amount of time uh, to do to get the features for like 1000 movies. So another thing is, as I mentioned, I used only free API, so might not have the full potential uptake. So if I have used APIs, the paid versions of the API, I could have gotten a better quota. Like in the YouTube API, they will give they will give unlimited amount of requests, and even in the Google Trends API, they will give unlimited amount of requests per second, per 0.5 second. As I can remember. So then I can train my model more fast, and then I also can increase my dataset for like a more like 10,000 movies. So then the model actually would be very uh, accurate in predicting flips and flops. And also another thing is niche area to study in Sri Lanka. So movies in Sri Lanka uh, is actually not that movie prediction is not that studied in Sri Lanka. So that is also a limitation of this project. So I had to do my research and get all the necessary details by myself, which I could have missed some details when I'm doing my research. So for the future enhancement, I obviously need to increase my dataset for a more diverse data, which I will be able to do only if I use the the paid versions of API, and increasing computer power of the backend to run a full scan on video and audio. So another thing is my model, when I said I'm running a video and audio analysis, I cannot run the video and audio analysis for the whole trailer, because to run the video and audio analysis on the whole trailer for the whole trailer, it will need more computing power, because there are two pre-trained models running at the same time, and this will often crash the PC. So uh, for the future enhancement, I need to increase the computational power to run a backend model with which can do the full scan. So, and also for the future enhancement, I need to do more enhanced explainability for each feature. So the stakeholders will have a good better idea on what actually is the problem for the movie to flip or flop. So next is the new skills and the list of and the use of existing skills I received and used when building this model. So for the new skills, I was able to identify what is Veda and TextBlog and API integration using YouTube, by which I have never done before. I have never used YouTube API and TMDB, even Google Trends API I have not used. And also XGBoost models, I have not used XGBoost models previously in my machine learning task. And React Flask full, I have done React specifically, but React plus Flask full stack development I have not uh, identified yet. I have not identified, which I did uh, learn from this model. And also agile development methodology, where I worked with the Gantt chart provided, and the use of existing skills. So Python programming, machine learning concepts, data processing, software engineering practices, model and testing, and UI designs. which I used, which these skills I already had, and I used to do when doing the project. So thank you. And so this is my CinemaScope AI, the multi-modal revenue prediction model using XGBoost. So thank you and have a nice day.